Okay, in this session I am going to tell you how to do the simple and multiple linear regression and how to test the direct hypothesis. It's very easy, very straightforward and very important, right? Okay. So this is the just to show you the simple linear regression model, right? Okay, in this case we are going to predict a value for a given x, right? So in this simple model, right? So this is your dependent variable, or this is your y value. So this is your x value. So all the x values are given. Now we are going to calculate the y value. That's what we are going to do in this simple linear regression. This is the error term. Now at this moment we are not going to talk about this value. It's okay. So this one is the intercept, which will be discussed in a few minutes time. This is called intercept, right? Okay. So this is the very simple equation for this particular model, and we will discuss later how this comes, right? So this is a very straightforward. I have to tell you, this linear regression is not a new technique. That technique is used 100 years ago, right? Those days you used by using pencil and a piece of paper. After that you used by using a big calculators. After that you use using small electronic calculators. But now you are using computers to do this calculation, and within fraction of second you will get your answers. Now you are using the computer. Now you will see within fraction of second you will get your answer, right? Okay, let's move on to that simple linear regression, right? So this is the model, right? So here you can see there are 7 lanes. Okay, you can see there are 7 lanes. So the land number 1, the fertilizer 100 kilograms have been put for the land number 1, and then the harvest is 40 tons, right? So similarly for the land 2, 200 kilograms per hectare have been put, and you have got the 45 tons of the harvest per hectare. So that's how. Now you are having set of data. For example, your company, your organization wants to know the yield for 800 kilograms. That is not measured here. Or else you want to, your company wants you to get the harvest for 1000 kilograms applied for the land number 8 or 9. That is not given here. So you have to calculate, you have to predict that value, you have to forecast that value. That is what we are going to do using the simple linear regression, right? Okay, how to do that one? So very straightforward, very simple. Just go to your data set. Okay, just go to your data set. Okay, just go to your data set. Right. So this is your data set. So as I told you very clearly, so all these values are given. Okay, and relevant yield is also given in the tons per hectare, but for this number of this 1700 kilograms of the fertilizer applied to this 8 land, that value is not given, right? So you have to calculate that value, you have to forecast that value, you have to predict that value. That is what we are going to do using simple linear regression. Okay, how to do that one? So very straightforward. Okay, very straightforward. Simply what you have to do is go to analyze, right? And go to regression, right? And then the linear regression, right? So you can see, okay, at your left side, all the variables are there. All the variables are there. We need our dependent variable. Just place it at the dependent variable box, right? So just click on top of this yield and then simply click this mark. That's one way. Or the other way, so if you want to take, this is your independent variable, just click it and drag on and place in the independent box. So these are the two ways that you can use to put your variables into the relevant boxes, right? Okay, that's it. So there are so many boxes in these options in this right side. Okay, so for the time being I am not going to discuss about these boxes. We will discuss one by one later. It's very simple, straightforward. Right, now what you have to do is simply click OK. You will get your results. Okay, within 1 minute, within fraction of second you get, right? So there are 4 boxes, no? Right. So what is this first box? Right. What is this first box? This box says number of variables you included, right? We included our dependent variable, that is harvest. Then we include only one variable, because simple linear regression means you are putting only one variable at a time. So that is what is given by this table, right? Okay, right. Now this is what is this model summary. It's a very important. What's that? That means the percentage of dependent variable explained by your independent variable. In this case variable, in the next variables. In this case we are having only one variable, that is why we call it simple linear regression. So this means 95.5% of our dependent variable is explained by our independent variable. That is a very good, but this is highly theoretical. When you are doing your own research, this could be somewhere 40%, 50%, 60%, 30%. That should be above 10%, otherwise it is not accepted. So please remember the importance of this R value. This is a very important, right? This table is a very important, and you have to interpret based on these values, right? In this case 95% of the dependent variable is explained by your independent variables. A very good model. Okay, right. So what is this chart? Table number 3, ANOVA. Yeah, this means that your model is significant as a whole. You are not going to interpret one by one, right? That is in the next table. In this table, the p-value or the sig value is less than 0.05. That means your model is as a whole significant, right? So please remember, in order to be significant, this sig value, this is called the p-value, should be less than 0.05. Okay, so please remember that very clearly. Okay, now this is our business area, business calculation, right? What is that? Okay, now here you can see this is your constant. I will show you later. And this is the most important, right? This is the most important, 0.068, and it is significant, right? As I told you very clearly, if this value is greater than 0.05, this is insignificant and the calculation is not valid. The model fails. Okay, so please understand. Right. Okay, this value, this is the constant, and the value is 32.857. That is also significant. So that means the model is clearly significant. I will later tell you how to build your model based on these values, and these two values definitely should be above 1.96, right? Please remember, these two values should be above 1.96. Then only these sigma values are less than 0.05, otherwise it will not be significant. So when the model is significant, when the relationship is significant, this value should be less than 0.05. This value should be less than 0.05. This value should be greater than 1.96 plus or minus, right? Please remember that. Right, now we already discussed it. Now we will see how to build this model. So very straightforward, right? Very straightforward, very simple. So these are the steps that you have to follow. So these are the tables that we already discussed. So this is the final table. As I told you, this is the beta value. This is the most important value. These two are most important values. right? And this sig values or p values, right? Because if this is p value is greater than 0.05, this is insignificant and we will reject the model. So in this case it is less than 0.05, so we accept the model. Right now we will see the what is the model, right? So based on, please remember that the model is built based on these two value. Since the sig values are less than 0.05, now we will see how we build the model, right? So this is it, very simple, right? This is the y value, your dependent variable, right? So this is the your intercept value. We already discussed that one. This is your business value, right? This is your business value. This is your x, or this is your independent independent variable, right? Now it is very clear the sigma value is less than 0.001, so therefore this model is accepted. Now what do you mean by this 0.068? So this is how you have to interpret, right? So please remember this interpretation. This indicates that the increase of 1 unit of fertilizer or else 1 unit of X, right? This fertilizer means X, right? So when you increase the 1 unit of fertilizer, the harvest or the Y will be increased by this percentage or this times, that means this value. So that is how you have to interpret. Okay. Now for example, in our case we already have the values up to the 7 lands. No, I think 7. So for example, your firm wants to find out your harvest for the 8th land for the 900 kilograms of the fertilizer. That's not there in the box. That you have to calculate, determine from this table. Simply you have to put 800 here. Okay, then you will get the relevant Y value approximately. I am not telling that this is 100% true, but based on your values, this is a approximated model fit, approximated. So please understand, right? Okay, that's all about the simple linear regression. So now we will move on to the multiple linear regression, right? Okay. So this is the model we discussed in our last session. So please understand the factors affecting to the purchasing intention of hybrid vehicles. Factors affecting to the purchasing intention of hybrid vehicles. So here you have 3 independent variables. That is the difference between the simple linear and multiple linear. Simple linear means you are having only one independent variable. Multiple linear regression means you are having 3 independent variables. That's only the difference, right? The technique is 100% same. This is your research interest or your dependent variable, right? So this is, please understand, this is a continuous type variable, directly immeasurable, right? You have to use a Likert scale 1 to 7 or 1 to 5. I have used 1 to 7, which was explained in my last video. Please refer that video for more information how to measure this one, right? Okay. So these are your independent variable, right? These are your independent variables, 3 independent variables. All 3 independent variables are continuous and directly immeasurable. You have to use the Likert scale to measure this one. I used 8 questions to measure this one, 9 questions to measure this one, 6 questions to measure this one, 3 questions to measure this one. That is a very unfair. Why? You have to get a mean value per question. For that you have to do a simple calculation. I will now show you how to do that. Very easy, very straightforward. You have to do that simple calculation for all these 4 constructs. Why? Because you have used a different number of questions to measure these variables, so you have to get the mean value. Okay, we will see how to get the mean value. Okay, right. Okay, right, very simple, very straightforward, right? Go to your data set. Okay, go to your data set. Go to your data set, straightforward, right? Very straightforward. Only thing here you have three variables, and another thing, in this case your variable, your constructs are not directly measurable. You have to use the Likert scale, right? So you can see here, so this is my HM, or the independent variable number one. I have used how many questions? 1 2 3 4 6 7 8, right? For the I have used 1 2 3 4 5 6 7 8 9, right? Similarly, I have used to measure the EM 6, to measure the PI 3. So you have to get the mean value of all 4 constructs, right? Okay, how to do that one? Okay, I will tell you, right? So please simply open up your data set, right? Go to the transform, compute variable, right? So please here write down HM. So we have to get the mean value. Okay, we have to get the mean value, HM mean, right? Okay, right. Please open up the brackets. That's it. Now take the average. Just sum up all these 8 scores and divide by 8. Then you will get the mean value. That's what, very simple, right? Just click it, okay, plus double click it, okay, plus double click it, okay, plus double click it, okay, and so on. You have to get the all 8 variables, right? Now how many variables are? Right, 8. Please make sure for no mistakes, right? Okay, now close the bracket and you have to divide by 8. Why? You use 8 questions to measure the construct HM, right? Okay, now simply click OK, right? Now you can see you have got a new variable in your variable view, right? So this is your new variable, right? This is your new variable. Okay, so this is your new variable, right? Okay, now you go to your data view and you will see this new variable at the very last column, right? Go to your data view and go to the last column. Okay, last column. Now you can see that your newly formed variable is here. Okay, well, similarly you have to calculate the mean value for all 4 constructs. I have already calculated for the simplicity to save the time. So this is the same value you can see. So this is my independent variable 1, or the factor 1, factor 2, factor 3, right? So this is purchasing intention of the dependent variable, right? The other 2 are for the mediator and the moderator. I will discuss those 2 later, right? For the time being, you have calculated the mean values for all these 4 indicators. Why? Because I use the different number of questions to measure this one. So I got the mean value, right? I got the mean. That's what I did, nothing else, right? Okay, so please remember. But if you use the straight away, if you use the directly measured values, for examples, number of fertilizer kilograms or number of kilograms of the harvest tons, then you don't have to worry about this one, because those are numbers. Those are not questions. Those are straight away you measure. But here you can't straight away measure. You had to use Likert scale to measure these things. That's why I got the average value, right? Okay, now how to do? So very simple and very straightforward, right? So the same concept, right? Same, nothing is different and nothing is difficult. Go to the analysis and regression and linear. Okay, and linear, simple linear, right? You can see now this time is your left side box is much bigger. Why? Because now you are doing your practical research, so therefore lot of variables, lot of data there, you don't have to worry about that. Okay, so what you have to do, just scroll down and see your mean value. of your dependent variable. This is my mean value. Just click it and click it. It is there. Okay. Is it understand? So I will reset it. Go to your mean value. Now these are values there you can see, but you have to get only the mean value. Why? Because you use the different number of questions to measure our 4 constructs. So therefore you have to get the mean value, right? So this is my mean value for the dependent variable. I will double click, or I will pick from here and place here. That's one way. Or the other way is, now I have already put my dependent variable in the dependent variable box. Now I have to put my independent variables in the independent variable box. Last time you remember that I had only one variable. This time I have 3 variables, so I have to put 3 types, right? That's it, nothing else. Okay, so this is my HM. Just click it and you can drag on and place here. That's the one way. The second way, another way is just click it and by using this arrow. Okay, and this is the third variable. Simply you have already put all these 3 variables into the variable box. Is it now you understand? Okay, very clear. Nothing different than the simple linear regression. In that scenario you had only one independent variable. Here you have only 3 independent variables. Even if you have 5 independent variables, you can simply use the same model. Okay, so please remember that this is a simple linear regression straight away, right? So you can't use this method to analyze the mediating or the moderating variables. For that, of course, you have to use another method which was developed by the Professor Andrew Hayes, which I already explained very clearly in my first video. So you can watch that video, how to download and install the process macro for the SPS that will be used to analyze the mediating effects. Not this one. This regression technique is to analyze the direct effects, right? Okay, clear. Now simply click OK. Right, now you got the similarly 4 tables like last time, but this time tables are much bigger, right? So please understand, much bigger, right? So this is the first table. Yeah, how many variables we entered? 3 independent variables, 1 dependent variable, right? So that's very clear. In last time 1 independent, 1 dependent. So this time it is 3 independent variables and 1 dependent variable, right? Okay, so this is the model summary. Once again, right, model summary means, can you remember last time it was somewhere around 95%? That is a theoretical. This is our practical. This is my own research. So you can see R has come down up to this level. What do you mean by this one? This one, my 3 independent variable explains 43% of the dependent variable. My 3 independent variables, my 3 identified independent factors or variables explain the 43% of the dependent variable. In other words, 43% of dependent variable is explained by my 3 independent variables. That means there are another 50% to be increased. That means there are another factors, 3, 4, 5 factors that will be for your further research to increase the R value up to somewhere around 75%, not to 90%, 75%. This is acceptable. Why? It is 43. If it is less than 10%, then that is rejected, right? Okay, and that's a very important one, the R square. You have to interpret this very clearly. You have to interpret, right? And then this is the ANOVA table. ANOVA table means as a whole your model is acceptable. Why? This p value or this sigma value is less than 0.05 means your model is accepted as a whole, right? You are not going to give anything individually. You are not going to give anything in detail, right? Now this is the last table, is the business area or business table. So this is very important, right? this is very important. In this table, you are given all the details, right? Okay. So what are how many variables? Right, 3 variables, right? Now check the p-values. All the sigma values are very good. All values are less than 0.05, less than 0.05, right? So now it is okay, right? Now it is okay. All the 3 values are less than 0.5. So significant, that means your all independent variables are significant. All independent variables are significant, right? At the same time, I already told you where this value should be above 1.96 plus or minus. So you can see values are more than 1.96 plus. Okay. So very clear. Now simply you can say that your all independent variables are significant. Relationship of your all independent variables towards the your dependent variable are significant. Now that's these 2 columns are okay. Now this is the most important column, right? This is the most important column. These are the what do you call that, fraction coefficients, beta coefficient. So by just looking at these values, so what is the most critical factor for the purchasing intention of the hybrid vehicle? So this is it, UM. This is the biggest value, right? So this is the biggest value based on my data set, right? Followed by this HM 0.220 and last by this EM 0.219. So according to this, you have to develop your model. What is the, so if this is your research findings in this context based on your data, out of these 3 independent variables, the most critical or the most key or the most influencing factor is UM. That means financial factors. That means that in other words economic factors. Second is HM. That means luxury factors. Third is EM. That means environmental factors. So that's how you have to interpret this table. I will clearly show you how it is interpreted, right? Okay, right. So these are the steps that we followed. These are the tables. So I already import all these tables. So this is for the descriptive statistics. This is for the correlations. I will discuss later when time comes. So this is the model summary. Okay, so how many variables you included, and this is model summary, that is R squared. So very important, this table, right? Very important, because this is your interval panel will ask, how about the R squared? Why it is low? Why it is too high? Yeah. So in this case, it is a medium. It's good, right? If it becomes less than 10, it is not acceptable. If it is 20-30, that is accepted but very weak. If it is up to 75, 60, 80, that's very good. If it is above 95, that is highly theoretical, right? Okay, so this is the ANOVA table that simply says your model is accepted as a whole. Right, now let's go into the next table and the final table. Right, this is your business area. This is your business area. Okay, so I already told you how to explain these values. You can see very clearly, we already explained. So these are the p values. Don't worry about the other values for the time being, right? So this value should be less than 0.05, then only you can say your relationships are significant. So these are the beta these are the beta coefficients. So based on these 3 values, you can interpret, you can say that you can conclude that in this based on this data set, the most important factor is UM. That means financial factor in the Sri Lankan context, right? The second is 2.22 by HM, means the hedonic motive, that means super luxury options, right? So that's all about the table of these coefficients, right? So this is another table I did not explain. I will explain later, and there are other values you need later, not now. For the time being, you need only this, and this value. These values should be above 1.96. Okay, clear? Right. So that's all about the multiple linear regression. Right. Now, interpretation that I have already explained you. ANOVA table, coefficient table, model summary. I have already explained you. And then this is a final interpretation. So already explained you. Right. Now, based on this this table, the most critical factor is UM 0.613, and the second value is 0.220. That is HM. The third one is 0.2. So that's how you have to interpret. So that is your recommendation. That is your conclusions based on your data set in Sri Lankan context, right? So the model summary also I very clearly explained the how to interpret the R value, and also I said very clearly the values of the, what you call it, the values of these coefficients. This this 0.613 means when you increase right? So please I will tell only for this one, right? When you increase by 1, when you increase by unit 1 by 1 unit, the PI or your dependent variable is increased by 0.613. So that is how you have to give your final interpretation for all these three variables, right? Okay. So that's all about the multiple linear regression. Now please understand, I have already discussed how to do the simple linear regression and how to do the multiple linear regression. The difference between simple linear and multiple linear: in the simple linear regression you had only one independent variable. In the multiple linear regression you have more than one independent variables. So that is all about how to do the linear regression, right? Okay, now next time we have to do the mediating analysis and the moderating analysis. Very simple. So please stay tuned with us, then you will understand how to do the mediating analysis and the moderating analysis. Okay, thank you very much. I hope that this session will be useful for you to analyze your data set to get the direct hypothesis. Please remember, this is just to get the direct hypothesis. For the mediating and the moderating, as I told you very clearly, you have to use the Professor Andrew Hayes process macro in order to analyze the mediating effects and the moderating effects. Okay, thank you very much. I hope this session will be very much useful for you. Okay.